Hello and welcome to Semaphore Uncut, a podcast for developers about building great products. Today I'm excited to welcome John Clingan. John, thank you so much for joining us.
Glad to be here.
Great. Please just go ahead and introduce yourself.
Sure, John Clingan. I'm a product manager at Red Hat, and I am kind of a community product manager of Quarkus, which I think we're going to talk about. But also, I am heavily involved in the MicroProfile community. So most recently, I am co-author of a book along with Ken Finnegan, who unfortunately couldn't make it today, on a book on developing microservices with Quarkus and MicroProfile for Kubernetes.
Some of our listeners might be aware what Quarkus is and how it works, and also about MicroProfile. But before we continue maybe and dive into more of the details, can you please give us a background, what they are and what's the community around them?
Sure. I'm going to begin a little bit differently in that I suspect some of your listeners have an understanding of what Java EE is. Historically speaking, they may have heard of it, maybe have even developed with it. But basically, Java EE is a collection of specifications. And those specifications used to be done in something called the JCP, the Java Community Process. Now it's moved into the Eclipse Foundation and was renamed Jakarta EE. So in your minds, just think of Jakarta EE as the way Java EE is going to move forward. And so you might think of Java EE in terms of Java application servers, but that doesn't necessarily have to be the case in a traditional Java application server sense. It took a long time for that to happen, for Java EE to kind of move from Java EE to Jakarta EE. So in the meantime, what we've done is we've created a new project, I guess you might call it. It's also in the Eclipse Foundation, called MicroProfile. And MicroProfile is about creating Java specifications for developing microservices. So think of things like configuration, externalized configuration. There's a modern REST client API invoking RESTful services, and there's a whole bunch. And there's also some interesting ones that tie into the Kubernetes aspect, like exposing health checks, like the health of your application to the underlying platform, like Kubernetes, and distributed tracing and stuff like that as well. So that's a little bit of background, very briefly, for MicroProfile. On the Quarkus side, your listeners will probably understand where I'm coming from here, in that, Java basically was getting a bit on the heavy side for doing cloud development. The Java virtual machine isn't necessarily the problem, but it's just the entire stack that developers were writing to. So a lot of that historically was based on Java EE or even Spring, which also leverages Java EE technologies under the hood. That whole stack was getting big and heavy, right? So deploying an application to a container could take a gigabyte of memory, for instance, for a typical pragmatic, application. So at the same time, Red Hat, who I work for, is traditionally known as the Linux company, right? But Red Hat has also moved a lot into Kubernetes, right? We have our Kubernetes distribution called OpenShift. And basically, the developers, our customers that are doing Java development, were actually considering alternatives to Java because it was rather large for doing containers on Kubernetes. And so they weren't getting the return on their investment in their Kubernetes clusters because they couldn't get the density of applications that they were looking for. And on top of that, even Red Hat's middleware products, like data grids, and you may have heard of Keycloak for doing single sign-on and stuff like that, were all written, using Java, using a traditional Java stack and frameworks. And those were also kind of getting rather large for Kubernetes environment. So we kind of went off and did a little soul searching and engineering innovation, I guess, and came up with Quarkus, which is a runtime that is very efficient, well, at runtime, right, in production, and also offers some really cool productivity features.
Hey everyone, Semaphore has published an open source book called CI/CD with Docker and Kubernetes. It combines just the right amount of best practices and practical advice for shipping cloud-native apps. Download your free copy today at semaphoreCI.com. In terms of concrete numbers, you were mentioning some, and I can relate to that. For instance, in our Kubernetes cluster running our production services, we are always fighting with that ratio between the CPUs that we are going to give to our Kubernetes cluster and the memory. What's the ratio, how we should configure those machines, and if and how we are scaling these services, especially in terms of memory. Can you compare, by contrast, what Quarkus brought to the game in terms of improving those numbers of the memory a microservice might require or performance?
Sure. And actually, before I do that, one thing I forgot to mention is I talked about two discrete technologies, Quarkus and MicroProfile. I should mention that Quarkus implements MicroProfile specifications, right? So that's the tie-in that I forgot to mention. So on the footprint aspect, if you go to quarkus.io, you can visualize what I'm talking about right now. There's a graphic there. It shows the performance results, at least in terms of memory footprint and startup time. Because in the Kubernetes environment, when you're spinning up containers, quite often startup time does matter. So with Quarkus, you could take a Java app, let's just say a hello world endpoint. That's all there is to it. If you take a look at a traditional cloud native stack, so there's lots of them in the Java world, right? There's Dropwizard, there's Thorntail, which we're essentially replacing with Quarkus. There's Spring Boot, and there's various ones. If you just think in that vein, I'm not going to point to any particular one. Just doing a hello world is 136 megabytes of memory. And by the way, that's the resonance set size. So that's not just a heap the Java virtual machine is executing. That's the total footprint of memory in a container, for instance. So 136 megs. If you run it with Quarkus on the JVM, on the Java virtual machine as normal, it's half that, basically. It's 73 megs. And then if you compile it to a native binary, so one of the neat things that Quarkus can do is actually take your Java application and compile it to a native binary. Now, since we're talking Linux and Kubernetes, really in this case, it's a Linux binary, but it can also compile down to Mac and Windows using Oracle's GraalVM technology. So you can actually get that down to a 12 megabyte memory footprint. For Java, that's actually pretty impressive.
Yeah, that's an order of magnitude better.
That is an order of magnitude better. Yeah. In fact, one of the things that we do, people tend to think of transactions per second. So what we do is we measure transactions per second per megabyte of RAM.
Mm-hmm. Yeah, that's interesting.
Yeah, it's a slightly adjusted approach to measuring it because in a containerized cloud environment, really the gating factor tends to be memory, right? Because as soon as you go above a certain amount of RAM, then you have to go to maybe a larger VM image, right? Virtual machine image in the cloud. So we try to kind of put that in context. So that's just memory, right? Now, if you look at the startup time, and so this is from starting the application to actually the first response back to the browser, right? Or back to the invoker. Now, in this example, if you take it from a REST endpoint to as in a CRUD application, create, update, delete to a database, right? So if you take that traditional cloud native Java stack, it's 9.5 seconds. If you run it on top of Quarkus, again, just running on top of the JDK, it's 2 seconds. And in terms of response time to actually receive data. And if you compile it down to a native binary, it's 42 milliseconds, right? From hitting enter to actually getting a response back from the browser, right? Hitting enter to start the application, make a request and get a response back. So this is important in Kubernetes, as I mentioned before, because you're always starting containers. It's important for serverless, where you're scaling from zero. And if you take the combination of these two things, it actually makes Java a very nice runtime for doing functions as a service as well, right? That's an area where Java couldn't even play before, using all the traditional APIs that Java developers are used to. If you just go into your, search engine and just type Quarkus IDC lab validation study, there's actually a study that puts dollars behind this, like how much money you could save by using this versus a traditional cloud native stack.
Yeah, it's quite impressive. I mean, I know most time that I spent developing was probably in the Ruby world, and Ruby is also a VM, and I know that there are like a decade-long marches before you achieve some major improvement in performance on whatever area. From the inception of this project, how long it took to, and what are maybe some of the major obstacles to reaching this goal?
You mean in terms of implementing and building Quarkus as a runtime?
Yeah, yeah. I mean, it's fantastic, but I guess it was not a super easy and very straightforward thing to do because, yeah, maybe if it would have, someone would have done it earlier.
Yeah, well, interestingly, it wasn't necessarily as tough as one might imagine because at Red Hat, we kind of have this unique combination of skills. Okay, I know I sound like I'm in marketing mode, and I'm not really trying to present it that way.
If it's the truth, it's okay.
Yeah, yeah. Well, it's definitely true. Where we have a lot of engineers working on a project called Vertex, which ironically is also an Eclipse project now. Vertex is a totally async, reactive runtime that is extremely performant and also has low memory utilization. But it's more of a lower level toolkit as opposed to a higher level programming model that most Java developers, enterprise Java developers, are used to, right? So we had a lot of experience there about doing reactive and async. So Quarkus can do traditional Java EE style programming, or it can do completely asynchronous reactive as well, right? You as the developer gets to choose the model that you want. So we had a lot of experience there that helps make Quarkus very efficient under the hood. We have a lot of JVM experts at Red Hat that work on and provide, even down to doing things like porting the JDK to ARM, writing garbage collectors. So I'm talking about very, deep expertise. And, they were also tracking what Oracle was doing with GraalVM, right? So, we saw this native compilation thing coming through, and it's like, okay, how do we take advantage of that? So that's kind of number two. Number three is we've got a lot of experience in writing Java frameworks, right? So we have in the Java world, again, I know that maybe a lot of your listeners aren't necessarily Java developers, but for doing persistence and object relational mapping, there's the most popular framework is Hibernate, and that is a Red Hat, started project. Another one is context and dependency injection, so basically inversion of control in containers and stuff. And that the most popular implementation there as well, which is a Red Hat project, right? So we have a lot of these deep experts in these technologies that enterprise Java developers rely on. So what we did is we went into those knowing what they are and basically either enhanced them or kind of wrote an alternative that better fit native compilation. And it wasn't necessarily always a complete rewrite from scratch. We just modified the frameworks that we had to take advantage of native compilation, right? So I don't know quite how long it took. As I mentioned, we had something called Thorntail. Wildfly Swarm is what it was called, and we changed it to Thorntail. And we had experience there. And so taking that experience with writing a standalone Java runtime with the Vertex stuff, with the JVM expertise, and I want to make sure I'm getting it all, the MicroProfile implementation experience that we got, along with the Java EE history, brought it all together. I don't know what it was, but probably about a year to kind of pull that all together and prototype it and kind of release it to the world.
It probably falls in that category of standing on shoulders of giants.
Yeah, absolutely.
Hey, I'm going to take a quick break here and tell you that Semaphore has a new book out called CI/CD with Docker and Kubernetes. If you are looking to deploy cloud-native apps, it's going to show you the most productive way of doing that. And the best of all, it's free. Download your free copy today at semaphoreCI.com. In order for developers who are, to me, maybe to majority of our customers, I mean, when you mention Hibernate, Spring, Spring Boot, all that stack, that's what most of the people, I guess, are exposed to. So making a step forward and embracing Quarkus, and also maybe, and we can talk about then the next step, bringing it to Kubernetes. What's the path? Is that something which you see in practice that people easily embrace, or?
You mean moving to Kubernetes?
I mean, someone who is used to, more of what you described as a traditional approach to embracing Quarkus and converting their stacks.
So if you come from the Java EE and Jakarta worlds, and MicroProfile is newer, it's probably about 5 years old now, 4 to 5 years old. then yeah, Quarkus is going to feel at home. But if you are a Spring Boot developer, then there is also Spring compatibility APIs. So you could use Spring MVC, Spring Data JPA, Spring Dependency Injection. If you're familiar with these APIs, you can actually use them with Quarkus. And we implemented it in a Quarkus native way. So all of those things actually compile down to a native binary and you get all those benefits I mentioned earlier. One other thing I'll mention is, before I talk about the Kubernetes move, is there's a feature called live coding. And so if you're a Node.js developer or you're, used to running dynamic languages, coding is very productive, right? Where you can iterate very rapidly because the runtime starts so fast or it automatically reloads code changes and so on. Quarkus does exactly the same thing. So you can make any change that you want to your Java code, to static files, to your configuration, to even if you're familiar with Maven, the PALM file or Gradle, it'll actually reload the application. It's pretty much instantaneous. It takes maybe a half a second in most cases to just reload your code changes. And so you get this very dynamic, highly iterative experience where Java developers basically in the past would say, I wouldn't try things out because it would just take too long. Now they're basically saying, well, now I can try out things that I wouldn't normally try out while I'm coding and not have to pay this large penalty. It makes it possible.
That was previously reserved to those dynamic, mostly scripting languages, and that was one of the very attractive things that they had to offer. So it's interesting to hear that it is now possible also in the Java world.
Yeah, and there's no IDE tooling involved, so there's no special plugins or anything like that. It's just the Maven or Gradle command line. You put it in developer mode, and it works in any IDE or even outside of the IDE, right? You can just go into a text editor, make changes, and it'll just dynamically reload them. So it's actually pretty cool. Now, kind of tying into the Kubernetes part of it, I'm going to jump ahead a little bit in that live coding that I mentioned can actually be done remotely. So you can have your application running in a container in a Kubernetes cluster and get the same dynamic live coding experience. So it'll dynamically sync all the changes to the back end whenever you make a change. So it's pretty neat that you get remote development as well.
So it's in that area of hot reloading, right?
Yeah.
So it's not going to reboot the app. It's going to have an impact on the live process, right?
Yeah, correct.
By process, I mean operating system process.
Yeah. It doesn't restart the JVM at all, which is why it's actually so fast. So again, if you're familiar with Java, it basically drops the class loader that loads all the classes into memory, drops that, recompiles just the files that change if it's Java files, and then just boots it all up. And that, like I said, takes like half a second or so. In my case, like 250 milliseconds. So it's actually pretty quick. Now, to answer your other question about adopting Kubernetes and how do developers kind of begin to make that transition from traditional Java application server to Kubernetes, it's actually because Quarkus supports most of the APIs they already know, it's actually very low overhead. It doesn't support all of Java EE. It supports most of Java EE web profile. And again, if you're not familiar with Java EE, I know some of this could be Greek. That's a saying here in the States anyway. It's Greek to me. But if you're familiar with those or Spring, then picking it up is super quick. If you're familiar with the programming model, it's also very quick. So just keep in mind that if you know any of those technologies I've been mentioning, you'll pick up Quarkus very quickly, get it running. And in fact, deploying it to Kubernetes is a single command line. It's, Maven, and then you basically say -d to set a property to deploy it, and it deploys it to Kubernetes. So it's a one-step deploy while you're in, developer iteration mode. I understand deployment pipelines are going to be different, but we try to make it as easy as possible running Kubernetes.
Yeah. And in the area of observability and monitoring and those areas, so I remember like roughly 3 years ago when we were transitioning to Kubernetes, one of the major challenges was how do we figure out monitoring? There is a lot of networking inside, done in a bit different way. A lot of things are dynamic, going up and down. which, we were not used to. So what's the state of that? If someone is creating a new app, what is possible to get out of the box without going out and figure it on its own? Also a question, to what extent the book answers those questions.
There's a few things involved. So Ken has actually written the distributed tracing chapter. I think that might already be out there in the early access program that lets you do distributed tracing via Jaeger, for instance, right? You can have Jaeger monitor the requests between microservices and get kind of a bigger performance picture. On the metric side, Quarkus implements microprofile metrics. So microprofile metrics, there's basically three scopes, I guess. One is every microprofile implementation has to expose a certain set of metrics. So think of them as just JVM metrics, or maybe how many CPUs on the system, right? Something that all vendors can support. And Quarkus supports that. The second is vendor-specific metrics. So as you add more features to Quarkus, you'll get a broader set of metrics that you can monitor. So with Quarkus, it's not like an application server where out of the box, it's every feature you could possibly imagine. Basically, you add dependencies for the features that you need. And so with Quarkus, as you add these dependencies, those dependencies are instrumented so you can monitor them, right, with vendor-specific things. The third one is application metrics. So you can write your own business metrics within the application and expose those as well. All of those metrics are exposed either via JSON format or via basically an open metric / Prometheus format. So then you could pull it into Prometheus and in Grafana. I mean, I do that all the time. And that's basically what the book is going to do, is show you what's out of the box, what you can instrument in your own code and how to do it, and then expose it to Prometheus using open metrics. And probably I'll do Grafana as well.
Yeah, and Prometheus and Grafana are really interesting industry standard. As far as I'm concerned, not a good idea, but let me say it anyway, it could be shipped with Kubernetes as built in.
Well, the first step was to get them as CNCF projects. So step number one, well, yeah, we'll have to see what step number two says.
Exactly. Yeah. When developers are first, interacting with Kubernetes, what are you seeing as our biggest challenges for people to understand when they are trying to wrap their head around, Kubernetes and the way it, as you said, scales, boots, monitors services?
Generally speaking, and I think you touched on it, it's the dynamic nature of Kubernetes with pods going up, up and down all the time, especially if you really begin to adopt a flow where, you might have multiple features, blue-green deployments or feature flags, and you really want to try things out. You could be doing many deploys per day, right? And it sounds like from what you described, your listeners are kind of along that vein. So you don't have a stable view of the world, right? Things are dynamically changing all the time. Well, you have an immutable container, right? Which is any changes that you make to a container, like if you write to the file system, it's going to be gone as soon as that container is rebooted, right? So, that's probably, in my opinion, the main thing. Kubernetes adds constructs that let you deal with those things, right? So services have a consistent name and a consistent IP address to the service, right? So you have consistency provided by Kubernetes in a very dynamic environment. You have the ability to mount volumes for persistent data. But by and large, you want to make your containers immutable, which means anytime you make a change, and this is a Red Hat stance, maybe not everyone agrees, but you want to make your containers immutable, meaning just expect it all to go away. Cattle, not pets. You don't want to treat each container as an individual thing that you have to manage. You make a change, you redeploy the application, even if it's a configuration change, like turning on logging or turning off logging, right? That's kind of how Red Hat looks at it. So immutable containers, that's a change that developers might have to get used to.
It's so easy to get many of them, and they will run on different machines. So chasing them around will not work in the same way that it worked before. Going into an instance and inspecting the state of a process is not how it's done anymore. At least that was one of the learning curves for us.
Yeah, your monitoring of metrics becomes important, writing out your logs. What a lot of people will do is, generally what you do is you either send your logs directly to, an Elastic search engine or something that you can then search, or you write it to standard out and let Kubernetes scrape it and push it to, some backend log query infrastructure. And then you can basically analyze what's going on, even live, right? And figure out what's wrong. But very rarely will you actually log into a container to debug things, right? Whereas maybe in the days of old, you would log into a production server and look at things. So that aspect's a little different.
Yes. You could run some things in a relatively primitive manner because, yeah, you had that disk is there and something is running and I can get into that and that will be around. While here, if you didn't scrape the metrics, if you haven't ingested the logs, somewhere else, it's just gone. Thank you for guiding us through Quarkus and generally this, let's say, step forward in Java community to make it more accessible for these new, very dynamic environments. And of course, good luck with the book. We're going to share the links to Quarkus website, to your book. And there was also one more that you mentioned about some performance statistics that were done.
Yeah, that's an IDC lab validation study where they basically validated that you get the cost, memory, and improvements that are being claimed.
Yeah, that's great. Metrics on all sides are always great, money included.
Yeah. One last thing, the book is available in early access, right? So you can go to the link in the show notes and you can actually start reading the chapters that are done and provide feedback, right? So Ken and I monitor the comments and make improvements to the book along the way.
Yeah, feedback always helps. Yeah. Okay, great. So thank you again for joining us and sharing all this, and good luck.
Thank you.